Okay, so this video will show you how to get the code to turn in for assignment 6.2, the full program listing. In the end, you're going to have a file that actually a program that runs and generates this graphic, just like this. We're going to be drawing a green line, a whole bunch of red lines, and drawing squares, circles, triangle. That's 3 lines that make up a triangle, adding some text, changing color, things like that. This ideally is something that you would do in the classroom as a group, guiding yourselves to the end result, and then turning it in. Unfortunately, since we're doing everything remotely, I mean, yes, you can still go to your book and read chapter 6 and look at the drawing introduction on page 97, or rather 92, and just do everything that it tells you and get to page 97. Now, I hope that everybody still has their books. I don't know if you have to turn them back in. I don't know if they're back at school. I don't know what the situation is, but the text is fully available online. It's not chapter 6 though, it's the old book. It's going to be chapter 5. I have a link to it right here that will tell you exactly the same things that the book does. So rather than you though, since we have this electronic opportunity, I still want you to see what everything in everything the book tells you, and understand what each of these things represent, all the commands, and we're skipping one of the assignments. You will not be drawing a pretty picture, although you could if you want to, I guess, but we're just going to be drawing regular lines and things like that. So that being said, let's go back here. We're going to get the template first, and it's the same template that we used before, or at least that I've used before. So before I even get started, let me see one of these windows that is already open. I guess I'll use this one. I'm going to go into repl.it, and I'm going to create a new file, new REPL, top right blue button in Python. Create it. I'm going to give myself more space as usual on the left. And let's see, I'm going back to the book. I hope that you have clicked already on the drawing introduction and moved down to 5:10 drawing introduction. Just before that though, there's this template. We used this in another assignment in the looping as well, and pretty much anything that has graphics. So what I gotta do is copy this code, go all the way from the top. These are just remarks. We're gonna be deleting these probably, but line 1 through line 61, I'm gonna select it, right click and copy, go back to REPL and paste it. At the very top, like I said, these are remarks, just notes from the author. Just to give us a little bit of space, we'll delete them. And we'll pretty much leave everything else the same. This basically just sets up the screen and prepares the system for graphics. I'll run it once to see what's going on. I expect to see a white screen pop up at some point, and there it is, and it's called My Game. I'll give myself a little bit more space. Make sure that if you're in REPL and you're using PyGame, that you do give yourself a little bit of space here to read, if in case there's any errors. Otherwise, there might be problems. I will make it just a little bit wider. No, not that much wider. I guess it's already horizontal. I'll leave it alone and go back to the drawing introduction. My hope is that you are reading the book, that you're reading the directions here. I'm going to give you the quick route, otherwise we'll end up with a very long video. This is, like I said, this is something we would do in class, and we would do it once, and that would be fine. Do be sure to check out the list of things that you can draw. There are directions by the PyGame people that actually make a lot of sense. Then they tell you a little bit more about what you can do with these, what kind of graphics you can generate. So what I'm interested in though is I'm going to come down to drawing a single line, because this is the first thing. Did I mention that this is what our final graphic will look like? Not very exciting, but it gives you an idea of the basic things that we can do. So let's see, what is the first thing that the book would have us draw? It's just that single line, and I see that it's going to be green. It's going to be dependent on the screen that's already loaded onto the program that we just pasted, the template, and it's going to be 100 pixels long. So this line right here, I'm not going to copy the remarks, just the line, the pygame.draw.line, etc. Select it and copy. Go back to REPL. Where can we paste these commands? Well, I think I already mentioned it before. It might have been another video though. So I'll scroll down here. On my line 41, yours may be different. It says drawing code should go here. This is a remark, so we can either leave it there or delete it. I'm going to leave it there. I'm clicking at the very end of the line, pressing enter twice, and then pressing Control V as in Victor to paste what I just copied. So now I expect this, that whenever I run it, it will do everything it did before, which is basically create a blank window that's painted white, and then it should draw a line. As you're doing this, play along with the code. You know, well, what could you do to make this different? Well, I know that it's 100 long and it's 5 wide and things like that. You can change these numbers and play with different results. Draw on the screen a green line from 0, 0 to 100, 100. So if we were actually drawing a grid, 0, 0 would be the top left, and then 100 to the right, 100 below would be right about there. If we wanted it to go 200 to 200 all the way down here, we would just need to change the code. Well, actually not 200, 200, but 200 to the right. I guess it's the same thing. I just got confused there for a while, but it's 200 and 200, and stop and run again. This will draw a longer line, and that's what happened. If you want to end up with the same image as the other one, just keep it with the same values. It was 100 by 100. Okay, so that's 511. 512, drawing lines with loops and offsets. So now there are some offsets here, and be assured that you read what all this is about. I'm going to skip, as I did in the previous example, the remarks, and start with y offset is 0, and copy those last 4 lines, and then in my code paste them right after the command that I did just now. Make sure that as you're pasting and typing, whatever you're doing, that see all of these tabs, how they're very definite, it's definitely set. Python is very capricious. It doesn't work well when the tabs are off, so I have to make sure that the tabs are matched. Y and while at the very left of the code, but the next 2 lines, each one of them needs to have a tab just before. So I'll stop this and run it. And now I have one green line followed by multiple red lines. So this was done with a while loop while the y offset is less than 100. It did it 5 times, and now we have those red lines. Moving on to the next one, I was thinking about originally just giving you the first few ones and setting them up as an example, and you could do the rest of your own on your own. If at this point you think you can do that, by all means, do it on your own. I'll do this for the benefit of everybody though, so I'm going to go to the drawing in a series of lines. Something that it's telling us is that the same code, the same thing that we did here, we could use a for loop. which is just a way of making the computer do things repeatedly in the same fashion. If you're going to type in the first one and then try out the second one, make sure that when you copy, you paste it on top of what you just did, because it's the same thing. So either pick this one, the one that you all know already works, and then replace it with the new code, or only use the first one. So this one has a for loop, for y offset in range 0, 110. So it'll do from 0 to 100. It'll step it. It will skip it 10 points at a time, and then the rest of the command, which is similar to what we had before. Let's stop and run that again. And I didn't expect any change, because basically it told us it was going to do the same thing, and it did. So going back to the text here, we've already run that code. The complex offsets, well, by complex I mean we're going to be using some complex math here. So it's giving me the same type of loop for I in range 200, so it'll do something 200 times. Radians, etc., sine and cosine. So these are trigonometric functions that I wish we had more time to explain. I'm going to copy that and go back to the code, the last thing that I typed in, right about here. Press enter a couple of times and then backspace so that it's set aligned with the rest of the code. Press Ctrl V to paste, Ctrl V as in Victor, and because this is a for loop, there is a colon, and then the loop itself will need to be tabbed. So make sure that that has the tabs attached to them. Same thing with the rest of that little function. So for I, radians needs to be tabbed, the X change and the Y change need to be tabbed, as well as the PyGame. And let's stop and run it. We may be getting an error here. And yes, math is not defined because we're using complex math. We've used math before, even though it's not so complex what we've done. But we still need to tell Python that there is such a thing as math. Just like we told it there's such a thing as PyGame, we told it to import it. I'm going to import math. And that way it will load up the math library. I'll run it again and see what happens. And what we expected, it does the sine and cosine. It drew a couple of waves. So I'll go back to my code, my line 57, press enter a couple of times after the end of the line, and delete or backspace once so that I am aligned once again with the program code. What follows next, multiple elements can be drawn in one for loop, and this is just basically a repetition of what we've done, except done a little bit differently. Next, a simple shape, a rectangle. Later on we have an exercise where we draw what appear to be small dots, but they're actually little squares, which are rectangles, very straight rectangles. Rectangles and circles are drawn in similar fashion. They have different commands. You just sort of have to look at them at the same way. That if you took Photoshop with me, I think that I've told you before that when we draw a circle in Photoshop, we're actually drawing a square, and this illustrates that concept perfectly, because the size, dimensions, etc. of the circle fit within the square, so they have very similar dimensions. I'll scroll down to draw a rectangle and copy the none hashtag. I'll copy that, go back to Replit, and after the last math in the space that I provided for myself, I will paste the code, Control V, and run. I'll stop the program from running and then run again. And you should be stopping and running every time to make sure that your code is always working, because if you say, well, I'll check it at the end, and you have to go back and debug, you might be spending more time than you need to. I'll give myself an extra couple of spaces, and the text now we will be drawing an ellipse. So ellipse is a circle, just like a rectangle is a square. It's the same concept. They explained a lot of it in the previous section. So I will copy the command to draw an ellipse. come back and add it where I need it. Press enter a couple of times, run stop, and then check the code. And it runs, and now I have a circle, and I have, or rather an ellipses, and I have a square. So I'm doing fine. I'm going to be drawing an arc. And an interesting concept in Python and in lots of different programming languages. I think that the JavaScript does the same thing, that in order to draw a circle, you have to draw an arc. And an arc is only part of a circle. So here they're showing us how the part of the ellipses that we're going to be drawing will actually come together as a circle. If you've taken some trigonometry, some advanced geometry or algebra, I don't know what the new math teaches you. Back in the day, they taught us everything in one class, and we did it all by hand and pencil. Not really, but I know things are different now. I'm going to copy that code that I just highlighted, the arcs. One will be green, another black, another red, and another blue. There's a lot of color declarations. And because we already imported math, it knows what pi is. And we used pi before, I do believe, in our first calculator exercises when we were determining areas and things like that, and circles were involved. I'm going to paste the copy, or rather the text that I just copied. Make sure that it's tabbed in correctly. Right there, and then the last one right here. And stop it and to run it. And an indent does not match any other indentation. So I think that as I was tabbing along, I didn't tab something correctly. I'm going to give myself more space. And let's see, I have a draw arc. Oh, here you go, the last line. I didn't do that, so I'm glad that I kept part of that window open over here. I'm going to click just before the last PyGame, press tab, give myself, or get back that space that I had and gave up, and I'll run again. Pi is not defined. Maybe I was a little bit too confident that math brought in the pi, but maybe it did not bring the pi, so how rude. What kind of a party are we going to have if we don't have pi? So I'm going to ask Google what is pi, and it's 314 something, and sure enough, 314 blah blah blah. I'm going to copy that, or you could do 314 15 9. And since it's not available right away in our libraries, I'm going to go to where we define the colors, and I'm going to say that pi is equal to the number we just copied. And let's try running it. And blue is not defined. No, we're not using blue. Okay, so all kinds of fun suddenly appeared at the end of the day. So the last time that I put in this pi and I added the space, did I delete something? Blue is here. Oh, but it's not defined. Well, of course it's not defined because we weren't going to use it. Okay, blue is equal to red, green, blue, so no red, 0, no green, 0, and all the blue, 255. Did I delete something? Maybe I did. If I did, I apologize, but I've just put it back. I'll run it, and now I have the circle made of arcs of different colors. Scrolling down here, and to the last of the arcs, pressing enter a couple of times to give me the space. I'll go on to the next one. We're almost done. We're going to draw a polygon. And this is, we're going to go from coordinate to coordinate to coordinate to draw a triangle. And it's going to go from 100, 100, so it's 100 to the right, 100 below, to 0 and 200, so it's going to go below that, the side, etc., and draw a triangle. Copy that and paste it on to the code. Control V to paste. stop the program and run it again. And there's a triangle somewhere in there, hidden along with all the other shapes. Let me get rid of pi. Drawing text, something else that we need to do. We can draw the text on the screen. We can select the system font. Oh, this is going to be interesting because Calibri is a Windows font. I am in a Chromebook. So let's see what happens. I'm going to copy everything and go for the gusto and see if it will give me an error. So the last thing that I did was draw that triangle. Press enter a couple of times after that code, paste. And I have a lot of text that I copied, so I'm going to make sure that it's all tabbed correctly. These remarks really don't matter, but I still will keep them apart so they're easier to tell where they are if and when I delete them. So right now all it does is says my text. Let's see if it will run that. Stop and run. If it doesn't find Calibri, it might give us an error. Oh, I have a weird indent. Where did I mess up with the indents? Indentation error. I can't tell. And now my dashboard has disappeared. Let me run this again. Stop and run. Well, I may not be able to see unless, is this it? If I click and drag, please. This is the fun of doing things for the first time while being recorded. At any rate, well, I'm not going to be able to get my dashboard back, I don't think, but I did see where my tab problem is. It's over here, and I'm going to tab that in and run it and see if while it's running, well, that helped it. My text is there somewhere. I can see it. I'm going to stop it. I wish I had this area back, but it's just not going to let me right now. So that's fine. View page source? No, that's not going to be it. Oh, shortcuts. Well, there were no shortcuts, but I mean, I know that it worked even though it's not Calibri. And can I change to where I put it? I probably can, but I'm not going to mess with it too much. I can change the my text to something else. I'll put it in my name. And I've already been talking for 20 minutes. So I'll stop and I'll run and I'll stop. And I should see my name in there. There it is. So fine. Let's go to the next thing. Full program listing. It should look like this, except mine, it doesn't say my text, it says my name. So hey, 23 minutes and a half, and this is all done. And for the most part, my graphic looks a little bit like this. This is taller, probably a PC as opposed to a Chromebook, but that's fine if yours looks like this with your name or not, my text. Yeah, let's have your name. You should be fine. So make sure that you save this. I don't remember if I gave this a name originally, but I can change it to what were we going to call this? Probably full program listing. So I'll call this edit and call it full program, full_program. Make sure it's an underscore. Press enter, and now my URL is replit/my username full program, and this is what you'll be turning in, the URL that will take me to your beautifully rendered program, and then move on to the next thing from here. We'll see you in the next video.